Good day, students. How are you? Now continue our video lessons. It is fifth video lesson, and the first topic is named the integral distributive function for the of the normal distribution. The integral distributive function, the integral distributive function of the normal distributive density. Nazaritis normal paylanma sıklığının integral paylama funksiyası. You know that the integral distributive function is denoted as f capital of x. And also remember the function, the normal distributive density. It is the following function: f of x is 1 over sigma square root of 2 pi multiplied by 2e multiplied by e raised to minus x minus a squared over 2 sigma squared. It is the normal distributive density. Then also you remember that the probability that the continuous random variable with will belong to the interval alpha beta is defined by the following formula: p capital of alpha is less than x is less than beta equals the integral from alpha to beta f little of x dx. And also you remember that this probability for the normal distribution has the following form. It is a general formula, but for normal distribution we obtain the particular case. P of alpha is less than x is less than beta is equal to 1 second multiplied by phi of beta minus a over sigma square root of 2 minus phi capital, it is capital Greek letter phi of alpha minus a over sigma square root of 2. It is the probability that the continuous random variable with the normal distributive density will belong to the interval alpha beta. Then you use these formulas, and now use these formulas. But also you remember the formula of the integral distributive function for general case. f capital of x is integral from minus infinity to x f f of x dx. But according to the formula of probability, it is p for p capital of minus infinity is less than x, it is less than x with line, is less than x. Here we must denote the continuous random variable itself by x with the line. And then here we must substitute minus infinity instead of alpha and x instead of beta. Equals 1 second multiplied by phi of here beta is x minus a over sigma square root of 2 minus phi of and substitute minus infinity instead of alpha, minus infinity minus a over sigma square root of 2. Then continue. Minus infinity minus a is minus infinity, and minus infinity defined by the positive number. It is positive number. Sigma is positive number. Then we will obtain minus infinity. Continue. Equals 1 second multiplied by phi capital of x minus a sigma square root of 2 minus phi of minus infinity equals already you know that the error integral is of the function, and therefore the negative sign can be taken out of the error integral symbol, and here we will obtain simply plus 1 second multiplied by phi of x minus a over sigma square root of 2 plus phi of plus infinity. And also you know that at infinity our function phi, that is error integral, tends to unit. It is tends to unit, and therefore we will obtain that the integral of this function has will have the following form: f of x equals 1 second multiplied by phi of x minus a over sigma square root of 2 plus 1. It is the expression of the integral distributive function of the normal distributive density. Now consider the properties and then construct the graph of this function. Properties. First property. Here we can calculate the value f capital of x at point x. If substitute a instead of x in this formula, then we will obtain f of a equals 1 second multiplied by phi of a minus a over sigma square root of 2 plus 1 equals a minus a is 0, phi of zero is zero according to the properties of error integral. 1 second multiplied by phi capital at 0 plus 1, it is 0. 1 second multiplied by 0 plus 1, and we will obtain 1 second. That is, f capital of A is 1 second. It is result, the first property. Then investigate the behavior of this integral discrete function at plus infinity, then at minus infinity. Continue here. Continue. Second property, limit f capital of x when x tends to plus infinity. Substitute plus infinity instead of x here. 1 second multiply phi of plus infinity minus a over sigma square root of 2 plus 1 equals infinity minus a is infinity, infinity divided by sigma square root of 2 is plus infinity, equals 1 second multiplied by phi of plus infinity plus 1, and phi according to the properties of the error integral at infinity tends to unit. It is tends to unit. Then we will obtain 1 second multiplied by 1 plus 1, it is equal to 1. Therefore we obtained second result, that limit f of x when x tends to plus infinity is unit. It is second result, and then consider the last result, third, and investigate the behavior of f capital of x at minus infinity. At minus infinity, limit f capital of x when x tends to minus infinity equals, substitute minus infinity instead of x in this expression. 1 second multiplied by phi capital of minus infinity minus a over sigma square root of 2 plus 1. Then minus infinity minus a, already you know that it is minus infinity. Minus infinity divided by sigma square root of 2 is also minus infinity again, will give minus infinity. And finally we have 1 second multiplied by phi capital of minus infinity plus 1. And phi at minus infinity is minus 1 according to the one of properties of the error integral. It is tends to minus 1, and therefore minus 1 plus 1 is 0. 1 second multiplied by 0 will give 0. Therefore already we have also the third result, limit f of x when x tends to minus infinity is 0. Because it is 0. Then construct, now we can construct the graph of integral distributive function. Function. Here the graph of our function has two horizontal asymptotes, y equals 1 and y equals 0. Asymptotes. This y equals 1, and y equals 0. They are horizontal asymptotes. And at the point A, here point A is symmetry center. It is mathematical expectation. It is expected value. It is also the scattering point. It is also the probability distribution center, scattering center, and also it is mode, and also it is median. And at this point, our function, the value of our function is 1 second. 1 second. One second. And then we can construct our graph. It is graph of the integral distributive function for the normal distributive density. Now I want to give you some information about terms on mathematical expectation. Mathematical expectation is named also expected value, and also scattering center, and also the probability distribution center. That is, the mathematical expectation has several names. First name, the names of the mathematical expectation, mathematical expectation. The mathematical expectation itself. Mathematical expectation. Expected value. Scattering center. Scattering in Azeri it is sepalenme. And last name also it is probability distribution center. Distribution center. They are in Azeri has the following meanings. Riyazi gözleme, gözlenilen qiymət, sepeleme merkezi, demek ihtimalın paylanması merkezi. Then also you know that I want to give you some information about the symmetry center of the normal distributive density. Also, it is mathematical expectation with these terms, and also it is mode and it is median. Then continue. Now consider the all names of symmetry center of the distributive normal distributive density. The names, right? The names of the symmetry center of the normal distributive density of the normal distributive density, normal distributive density. First, construct the graph of the normal distributive density. Remember the graph of the normal distributive density. X is normal distributed density, 1 over sigma square root of multiple square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared. Here it is symmetry point, symmetry center. Symmetry merkezi. Now write the names of the symmetry center. First name symmetry center itself. Symmetry center. Then it is also the mode. Why? Because what is mode? Mode is such a value of the continuous random variable at which the distributed density has the greatest or maximum value. At this point, our function has maximum value. Mode, then median, because our function is a symmetric function with respect to A, and for the symmetric function, the median is equal to the symmetry center. Median. Then also, you know that for the mathematical expectation of the continuous random variable with the normal distributed density is equal to the symmetry center. It is also mathematical expectation. Then, remember all similar terms for mathematical expectation. It is also the expected value, also it is scattering center. Scattering center. And finally, it is also is probability distribution center. Probability distribution center. Then we will use the concept of the symmetric interval. What is symmetric interval? The interval of type A minus L, from A minus L to A plus L is named the symmetric interval, and here A is named the center of symmetric integral, and L is radius. A minus L, A plus L. It is the length of this interval is L. Length of this interval is L. And it is radius. A is symmetry center. Symmetry center. And L is radius. We will use this concept of symmetric interval, and now write the following topic: the probability that the continuous random variable, with the normal distributive density, will belong to the symmetric interval. Just our new topic. In reality, it is paydama sıxlığı normal olan kəsilməz təsadüfi kəmiyyətin simmetrik aralığa düşməsi ehtimalı. Remember the formula of probability that the continuous random variable with the normal distributive density will belong to the interval alpha beta. P cap of alpha is less than x is less than beta is equal to 1 second phi of beta minus a over sigma square root of 2 minus phi of alpha minus a over sigma square root of 2. Already you know this formula, but in our case, alpha is A minus L and beta is A plus L. Substitute A minus L instead of alpha and A plus L instead of B. Let alpha is A minus L, beta is A plus L. Then we will have P of A minus L is less than X is less than A plus L equals 1 second multiplied by phi capital, substitute A plus L instead of beta, A plus L minus A over sigma square root of 2 minus phi of, then substitute A minus L instead of alpha, A minus L minus A over sigma square root of 2. Here we can remove A and minus A minus A. Then we will have equals 1 second multiplied by phi of L over sigma square root of 2 minus phi of minus L over square root of 2. Continue. Then continue. Also, you know that the error integral is odd function, and therefore we can take negative sign out of the function symbol. And here we have minus will give plus, simply plus, equals 1 second multiplied by phi of L over sigma square root of 2 plus phi of L over sigma square root of 2. They are the same terms. 1 second multiplied by twice phi capital of L over sigma square root of 2. Here 2 and 1 second are simplified, and finally we have phi of L over sigma square root of 2. Thus P capital of A minus L is less than X is less than A plus L is equal to phi capital of L over sigma square root of 2. It is a very nice formula, and you see that this probability doesn't depend on the symmetry center, because here the letter A is absent today. Consider next topic named 3 sigmas rule. 3 sigmas rule. Sigmas, 3 sigmas rule. Remember the probability. That the continuous random variable with the normal distributive density will belong to the symmetric interval from A minus L to A plus L. P of A minus L is less than X is less than A plus L is equal to phi of L over sigma square root of 2. Already you know this formula. Then substitute 3 sigma instead of L. Let let uh, let L is 3 sigma. Let A is 3 sigma. 3 sigma. Then substitute 3 sigma instead of L in this formula. P capital of A minus 3 sigma is less than x is less than A plus 3 sigma equals P capital of 3 sigma over sigma square root of 2. Here we can simplify numerator and denominator, the numerator and denominator by sigma, then we will have phi of 3 over square root of 2. It is approximately is equal to phi of 3 divided by 1.4, and it is approximately equal to phi of 1.2, and it is approximately equal is unit. It means but it is probability. But you know that the probability of some event is equal unit. It means this event is a certain event. So what is certain? A certain event in nazar is yaygın hadise. It means the continuous random variable with the normal distributed density always will belong to the interval from A minus 3 sigma to A plus 3 sigma. But our probability doesn't depend on symmetry center A, therefore we can write also P from minus 3 sigma to plus 3 sigma. Therefore we can write P capital of interval from minus 3 sigma to plus 3 sigma, is approximately equal to 1. It means our continuous random variable was a normal distributive density will belong to the interval always will belong to the interval minus 3 sigma. Here sigma is the quadratic deviation. Mean quadratic deviation, or also it is standard deviation. Here, where sigma is named the mean quadratic deviation, or simply standard deviation. Or standard deviation. Dear students, today our lesson ended, and I wish you successes and good luck. Goodbye, students.